Hello, and welcome back to another episode from High Water Studio. Today we're going to be talking about the fundamentals of engineering exam, specifically for environmental engineers. Now, you probably already know about this exam if you're watching this video. It's basically a 4-hour exam in the morning over general engineering principles like your engineering sciences, and then it's followed by a 4-hour exam in the afternoon focused on your specific field of study. And so we're going to focus on environmental engineering for that second half. Super challenging test for new engineers, for recently graduated undergrads or about to graduate undergrads. I'm going to try to see what kind of interest there is on this. And we're going to run through 3 problems real quick and talk a little bit about how they might apply to the exam. So our first problem, actually, wish I would have wrote the problem out already. Oh no. Oh, there it is. Okay, sorry. So the first problem, that's pretty common. It's going to be some kind of measuring out of a solution, how to dilute a solution, prepare a solution, or balance a solution, something like that. So the one we're going to look at and actually solve here is going to be neutralizing an acid and base. So for example, if you have a 4 molar solution of a obviously very common acid, hydrochloric acid, and you want to add that to neutralize 40 milliliters of a 6 molar solution of sodium hydroxide. Obviously, molar is moles per liter. And so this is relatively simple because in this case we have monovalent acids. We only have 1 hydrogen, 1 hydroxide per mole. So when this is going to fully dissociate, both of them are going to fully dissociate because they're strong acid, strong base. And you're going to get, in this case, you're going to get 4 moles of hydrogen per liter. You're going to get 6 moles of hydroxide per liter, right? So it's pretty straightforward. In this case, you just need to do basically a weighted average between the two. So what we do, and we do this all the time in our labs for preparing standards, and maybe I'll talk a little bit more about that afterwards, but it's basically V1 is equal to C2 V2. So in this case, we know C1, actually I'm just going to go ahead and say 4 times V is going to be equal to 6 times 40, right? And so if you solve for V, you just have 60 milliliters. And you can take a look at the units and everything, obviously they're going to be equal. But what we can talk about is some of the things that they might try to do to throw you. This works because, like I said, they're monovalent. If you had something like sulfuric acid, this isn't going to work. Well, at least not as easily, because you're going to have hydrogens coming off at different pH values, right? Your second hydrogen is going to come off at a different pH value. And they're going to have different equilibriums because it's not exactly the same as being a strong acid, at least not a monovalent strong acid. Another thing they might try to do is make you use some of the molecular weights. So if they were to say something like, you want to make 10 milligrams per liter silver solution using silver nitrate. And so obviously you can't just weigh out like 10 milligrams into a liter and get 10 milligrams of silver, right? Because you need to look at the molecular weight between the two to see how much you're going to need more silver nitrate to get 10 milligrams per liter of silver. So hopefully that makes sense. Okay, so can I just clear all this? No, I can't. It's been a while. Let's just do a new layer. All right. All right, so another one that you're going to see almost, I mean, I don't want to say certainly because anything can be on there, but you're probably going to see some kind of problem about decay. And we actually have a video that talks about decay in a stream. Actually, it's going to be pretty similar, but we're going to work it backwards. So in this case, we want to see benzene decay, and we're going to have we're basically going to give you all the information except we want to find out what is the original concentration. We're going to back calculate to the original concentration. So we know that in this case our decay rate is going to be 0.20 per day. Our time that we are taking our measurement is at 12 days. So in other words, benzene has been in the environment for 12 days and then we've measured it. And our concentration at 12 days, or CT, is going to be, in this case, we'll just say it's 8 milligrams per liter. And so we want to find CO, our original concentration. So the basic equation for first order decay, so benzene in this case is going to be first order decay, and they're almost certainly going to tell you that. Or they might, the whole question might be just what is the decay order, decay rate. So in this case, for first order decay, we're going to have the original concentration is going to be equal to concentration at some time, E to the decay rate times time. And if you want to know how we get this, I believe we talk about that in our decay rate video that we have. So I mean, really it's just a plug and chug at this point. This is basically the thing you need to know. So we want to solve the original concentration. We know that we have 8 milligrams per liter. We have E, we have 0.20 per day, I'll just say day, times 12 days. And so this is going to be 2.4, and then this becomes so basically our C0 is going to be about 88 milligrams per liter in this case. Okay. And you know, you're going to get probably some kind of combination of this type of question. It might not be trying to find the original concentration, but it's going to be one of these variables that we have up here. Or it's going to ask you, or maybe in addition to that, ask you about, like, is this first order, zero order type of question. All right. Our third question. This one's going to be about setting up equilibrium coefficients and when you have products and reactants. So in this case, our basic form for equilibrium coefficients are going to be You can probably hear my kid talking in the background. Alright, so this form basically equates to A plus B C N plus D. And so if we wanted to ask, like, all right, what is the equation for something like, it almost doesn't matter what you ask now once you know how to do it, right? But say something like this, where we have these exponents, right? And now the important thing that is important to remember is that this is products over reactants. Hopefully I spelled that right. So, right, this is going to be the products, this is going to be the reactants. And so in that case, you're going to have why did I put a C there? Sorry about that. I don't know what I was thinking. It's supposed to be 2. All right, so 2B. Come on. And here we have 4C plus 3D. So this would be your equation that is going to be equal to this sort of equilibrium coefficient equation. To maybe differentiate between the two there. Okay, so that is all we have for this first part on our look at a study guide for fundamentals of engineering, environmental engineering exam. If you're getting ready for that, good luck. It's definitely give yourself a lot of time. I mean, if you can give yourself a year to prepare for it, that's the best thing to do. And really, spread it out over a long period of time. Don't try to cram for it. It makes it just stressful. All right, well, if you guys want to see more of this, if this is something you're interested in, I don't usually ask for likes, but if I can get some likes on this and see that there's an interest, then we'll definitely do some more of them. But either way, thanks for watching.